Once again, welcome to Physics STPM. I am Mr. Koo, your instructor. Let us begin with the topic for today. Okay, today we are going to center our mass. Okay, as I said, accumulate all the formulas that you need to remember. The computer is three subtopic under number 3 of the syllabus, dynamic. So today we are going to center our mass and 3.5 frictional forces. As syllabus is concerned, we have to define center of mass or system of particles in a plane. It's two-dimensional. Predict the path of the center of mass of two particle system. Okay, so remember when you ask to define, you have to remember that, memorize it. And under frictional force, explain the variation of frictional force with sliding force. Define and use coefficient of static function. I think this is static friction for function. And coefficient of kinematic friction. Okay, let's start with center of mass. Projectile. It's when we throw the ball, when a baseball is thrown in, it follows a smooth path. Because basically it behaves like a particle. The baseball follows a parabolic path like a projectile. But when we have a body, when we throw a baseball bat, however, its path or trajectory does not seem smooth at all. When we look at it, the handle there, you can see that it doesn't have a smooth path at all. Okay? But if we look at the center of mass, you can see a point there, the red dot there. The bat rotates about the center of mass. Right? It rotates. You can see that it rotates about the center of mass. The center of mass itself follows the same path. Follow the path of the projectile. The center of mass, the smooth path. Parabolic path that we expect for a smaller, simpler object like baseball. Center of mass. Center of mass of a body is a point. Right? It's a point that accelerates when the external force is applied. Here, the external force is the weight, the force of gravity pulling it down. Right? Center of mass is the point that accelerates when the external force is applied. There's no rotation. Right? The point is always there. It doesn't rotate. This handle will rotate, but that center of mass doesn't rotate. Calculating center of mass for two particles. You can choose your origin, it's your choice. You can choose your origin here, or you can choose an arbitrary origin. That's the origin. That's the x-axis. Let's call M1, that particle, the mass M1 at a distance x1 from origin. And then M2, at that mass there, a distance x2 from origin. Then the center of mass must be between each of them. The center of mass. That's how simple of center of mass. So center of mass is a unique point. One point only. It's like balance of a seesaw. That means you put a seesaw there, you put a fulcrum there, it is balanced. The clockwise moment equals to the anti-clockwise moment. About the pivot point with respect to the torque produced. Torque is just the force times the distance, which we'll study later on. There's a pivot on the fulcrum. For two masses is defined as okay, each one is just m1 times the distance x1, m2 times the distance x2, and then the total mass times the center of mass, divided by total mass. Two mass is defined as that if the origin is at the center of mass, origin is here. If we take origin as here, center of mass, this will be 0. Right? Then cross multiply, that will be 0 also. So we are end up with this one equals to 0. But it's important to realize if we take this as origin, to the right is positive, conventional rule, and to the left is negative. That's why I have to put a negative sign here. Then we get m1 x1 equals m2 x2. Like moment, just like moment about the fulcrum. For identical mass, then x is the center of mass is the midpoint. Sorry for the mistake there. Okay, so we can go for a general case, right? A body with different masses there, right? You got n particles make up the body. A body is made up of many particles. Let's call n of them. So particle P, as a particle P, is a distance x1 from y-axis, a distance y1 from the x-axis. Particle Q is a particle Q, a distance x2 from the origin, from the y-axis, and a distance y2 from the x-axis. Right? Same with the n particle. With the n particle, xn from the x-axis, and xn from the y-axis, and then a distance of yn from the x-axis. Same thing. Right? Each particle has a mass times its distance, and divided by total mass. Right? Or mass of the body. Right? If calculating center of mass of system or particle about the x-axis, just now was the right now is the x-axis, just now was the y-axis. So instead of x, we replace that with y. There's a center of mass somewhere around here. Same thing, we just take your m1 times the y1, m2 times the y2, add them up, and then this is the total mass. Right? This is memorized. Center of mass and center of gravity. Center of mass and center of gravity are the same point. They are the same point in a uniform gravitational field on Earth. Right? Any body, any object, the center of mass, center of gravity are the same because your gravitational field strength is uniform. Center of gravity is a point where the weight of a body appears to act. Right? So we always represent a body by center of mass, and the weight will act at the center of mass or center of gravity. Solving problem. Yes. This one is taken from the revision book. Quick check for page 81. Find the position of center of mass of a system shown in the figure. It's always better to buy some books so they can, even though it's not the official textbook, it's good enough to give you a chance to do some exercise. That's why I stress you can't study physics by just reading and attending lecture. You must understand the lecture and then try out some solving problem. Right? This is the book that I use. Reasonable. Right? Don't call mistake, right? It's reasonable. You can try this one if you want to. These are the two books that I'm using. Syllabus is sometimes not clear, so you have to use past year paper to help you make it clearer how wide the question can be. Because sometimes it's very difficult to interpret from the syllabus. And some of the questions are taken from A level, Cambridge A level 9702. This one you can Google it and you can get all the question paper on the internet. Okay, so that's where I got it. Question from this book. See, they are both from the same author. Okay, find the position center of mass of a system shown. So just use the formula, understand the formula. There are 4 particles there. Right? Sum of each mass times the distance. So that distance is from y-axis. That distance we want. The first one is 6 times 0. 6 times 0. 8 times 2. 8 times 2. This 2 times the distance. 3 square if you like. 2 times 3. And 4. There are 5 square here. 4 times 5. Then we add all the mass together. That's a total mass. Then use calculator to calculate out. So from the x-axis, from this x-axis, same thing. That's the first one. From the x-axis, that's 3. 3 times 6. 3 times 6. 8. Right? 0. 0 from the x-axis. 8 times 0. This one is 4 square. 4 square times 2. 4 times 2 or 2 times 4. This one is 5 times 4. Sorry. No. This is 2 from the x-axis. 5 from the y-axis. Don't get confused. Right? It's 2 from the x-axis. 2 times 4. And then this is the total mass. Add all these mass together. That's all. It's calculator. Okay, have a go at this one. Stop your video. Try this one. This is a past year question. The Earth-Moon system is shown in diagram below. Draw the diagram itself. That is your distance A. That's your distance B. That's your big M. That's your small m. Which statement is true about the center or mass of the Earth-Moon system? Right, work it out. Right, just assume that there's a weight coming down. There's a weight coming down. That's all. If you've forgotten the formula, then take moment about center of mass. You got your m times A, m times B, and then work it out. Since your m is greater mass, greater than small m, right? You look for this formula. These are equal, but m is larger. So it means that B must be smaller. Keep this equation, B is smaller than A. Keep this equation balanced. Right? So answer A. Center of mass is nearer to the Earth. It's always nearer to a larger mass. Right? Because if it's larger mass, that must be smaller. If it's smaller mass, that must be larger. Right? So both Earth and Moon rotates about the center of mass C. Okay, let's go to the new subtopic 3.5 frictional forces. Always remember friction or frictional forces opposes motion. Direction of friction or frictional force always oppose motion. So you must see where is the motion. You are pulling it to the right, so friction force is to the left. Forces acting on a body being pulled. Right? That's your applied force. You are the one who pull it. That's the applied force. This is your wooden block. That's your center of gravity or center of mass. There's a frictional force, that one. There's a rough surface. Rough surface means it has friction. And applied force increases the frictional force. Right? As this applied force increases, that frictional force also increases. Increase to a maximum value called the limiting frictional force. After that, it will accelerate. Right? So if this is small, this is also small. But this one increase until it's equal to this limiting frictional force. If this one is greater than limiting frictional force, then the wooden block will accelerate. When motion occurs, the friction decreases to kinetic friction. So when it is moving, that one will decrease a little bit to what I call kinetic friction. Right? This is called static friction. Since the surface and the block are in equilibrium, right? This before it starts to move, this is maximum. That's your weight. That's your normal reaction. N. So N is balanced by W. That's why that it doesn't move vertically or downwards. Then the frictional force is balanced by the applied force. That's for equilibrium. You'll study later on in the syllabus. So we define coefficient of static friction. Static friction. Right? We use a symbol mu as the ratio of limiting frictional force to the normal reaction. So at 1 divided by N. Right? Of course, since these two are equal, we can replace the N by W and the F by the applied force. Right? So the coefficient is constant for two given surfaces. Right? These two surfaces, the rough surface and the wooden block surface, is constant. It depends on the surface in contact. Right? What type of surface they are in contact, and independent of the surface area. Doesn't depend on the surface area of the surface. For two particular material, the friction force is constant. That's what it means. Right? So we can replace that. That is our definition. But to calculate it, we can replace this one. Replacing that, W replaces N. Okay. So remember that this is from the topic what? I think from the topic under vectors. I can refer to that. There's your block, there's your normal reaction, there's your weight from the center of gravity, this is your inclined plane or slope. The plane is inclined with angle theta to the horizontal. Right? So normally we would choose a axis parallel to the plane and perpendicular to the plane. So we will resolve the weight. So this is theta. So that's W, so it's W cos theta. That's W sin theta. Memorize it, then it's faster. Forgotten, then you derive it. Right? So that is W cos theta, W sin theta. If the block is on the point of sliding, you can increase the angle, then the frictional force will start to increase. Right? So it's on the point of sliding, then this is called the limiting frictional force. Balance the component of weight down the plane. So it's going to slide down, so the frictional force is going up the slope. Right? So in this case, it's on the point of sliding, then the frictional force up the plane equals to that. That's your frictional force. Then the normal reaction is normal equals to weight, but equals to this component, W cos theta. So the coefficient of friction or static friction, mu, is F divided by N. F is equals to that. N is equals to that. Substitute that. Cancel the W, become tangent theta. You can either memorize or derive it. Mu can be determined by measuring this angle and taking the tangent of this angle. Coefficient of kinetic friction for moving body. Kinetic is moving lah, kinetic energy lah, moving body. Same thing. When the block is moving with constant velocity, the limiting frictional force becomes kinetic frictional force. Coefficient of kinetic friction, you just put a K there to show there's kinetic friction, is defined as a ratio of frictional force. Ratio of this one to that. Same definition, except we replace, instead of static friction, we replace it kinetic frictional force. Right? Frictional force over normal reaction. You have to memorize all this. And it's constant between two particular surface. On two particular surface is constant. It depends on the surface in contact. Means the type of surface that is in contact lah. Independent of the surface area. Right? Surface area, that one lah. Area on top there. We imagine 3 dimension. Right? And it's also the same. Equals to that applied force when it's moving with constant velocity. The applied force equals to frictional force, and replace the normal reaction with the weight. Right? These are some of value. Don't need to memorize. Not to memorize, but know the value is less than 1. Always remember, if your answer is more than 1, means some calculation mistake. And your coefficient of kinetic friction is less than coefficient of static friction. That's all you need to remember. Right? If you wood is about varies. Ice is very small. Right? Solving problem. Let's try solving some problem. To reinforce, as I said, try out a question in the revision book. A large block of ice is being pulled across a frozen lake. Ice against ice. The block of ice has a mass of 300 kilograms. The coefficient of friction between the two ice surface, mu is 0.05. What is the frictional force that is acting on the block of ice? Okay. You can draw the diagram. Then you know that this question is taken from this reference. If you're interested in this also. Here's our definition. Frictional force over normal reaction. Go to definition. And then remember that your normal reaction equals to weight equals to mg. Calculate out 300 as 9.81. Calculate out. And there, and across there, the frictional force is mu times n. Right? Or mu times that's your n. Calculate out 147 Newton. Right? Then we'll go at this one. Or stop the video as you try that. A coin is placed on top of a block as shown in the diagram below. If the coefficient of static friction between the coin and the block is 0.3, what is the maximum acceleration of the block so that the coin does not slip? Right? Don't focus on this surface. Focus on these two surfaces. Okay. So since you are going to calculate friction, use the formula F equals to mu n. Replace your n with mg. Okay? Work with what is given first. Mu is given. Mg. M is the mass of the coin. Acceleration of the coin. Applying. Right? So acceleration of the coin, it means that you are applying a force that must be equal to the frictional force. So your frictional force, which is this value, equals to that force you can obtain from by MA, mass times acceleration. M and N can cancel off. Then your A is 0.3 times 9.81. The answer is point B. Okay. Number 8. This is from a past year question also. 2018 or 2019. A stone of mass 345 kilograms is placed on an adjustable plane. That means it's going to be a slope. The worker has raised one end of the plane to move the stone down the plane. The angle of inclination of the plane is 30 degrees when the stone starts to move. What is the coefficient of static friction between the stone and the surface of the inclined plane? Right? As I said, you either memorize the formula or derive it. That's the formula that we are using. That one. Or draw a picture. As I said, always draw a picture that can imagine, visualize what you are doing. Right? Is replace your mg with mg sine theta, mg cos theta as your normal reaction, as friction. Right? Friction is just mu times n is just that value. Sorry, n is equals to this value. Right? That's why you get that times mu. Replacing mg with its component. That's what we do. Right? Parallel and perpendicular to the plane. For sliding, equilibrium perpendicular to the plane. Right? That one equals to that. You can memorize the formula, use it straight away, which is faster. If not, as I said, derive it. This one, balance the normal reaction. That's what we are saying. Resolving parallel to the plane, which is this one. Frictional force balanced by your mg sine theta. Right? So frictional force is mu n. Then replace your n with m. Right? N with that one. And cancel your mg. Okay. The answer is A. Okay, let's try one more. This is 2020. An object of mass 0.35 kilogram is pulled from rest along the rough surface of a table by a horizontal force of 5 Newton. If the velocity of the object is 4.0 meter per second after it moves 1.2 meter, what is the coefficient of friction between the object and the surface of the table? Right? Well, I'll draw a picture if you like on the paper itself so that you know pictorially how it works. Right? That's the applied force. That's the frictional force. That's your weight. Right? Since you are given a distance, right, you pull from rest distance, then you want to calculate the applied force or the acceleration first. Right? So take this one across there, divide by 2s to find the acceleration. Put your value in. That's your final. You start from rest, 0. And then that's your 2. This is your 2. Distance move is 1.2. So you can calculate your acceleration. Right? Newton's second law to calculate your resultant force. That one there. Right? Sorry, not this one. The resultant force is the applied force minus the frictional force equals to MA. Okay, this one minus that, give you MA. So that is your applied force. That's your applied force, horizontal force. Minus your mu, mg. And this equals to your mass. That's your mass times your acceleration. Okay, then we can put in your value for calculate this one out. This one out. And take this one across to the other side. So it's 5 minus this value, which is that, divided by mg. M is 0.35, G is 9.81. Get your answer. Answer is B. Okay, thank you for joining me for this session. We'll see you again next time. So we will end the session here. I'm Mr. Koo. Thank you.